Hello everyone, welcome to Edupedia World Videos. In today's lecture, we will discuss metals and non-metals. And today's lecture is covered under the following heads. First, we will discuss classification of elements. Out of 117 elements known, about 80% are metals. Many usable materials on the earth are metals and only 19 elements are non-metals. The metals used by us in our daily life are iron, copper, aluminium, lead, nickel, chromium, mercury and zinc. The economy and prosperity of a country are dependent on the natural resources produced by that country. Metals being very important natural resources, and they have played a key role in the history of civilization. Metals and non-metals have extensive uses in various fields. Metals like iron, aluminium, etc. and their compounds find application in household articles, constructions, biomedical implants, space research, etc. There are some metals like silver, gold, platinum which are very less reactive and hence found in nature in a free state. These metals and their compounds are used in jewelries, coins, chemical laboratories, photographic films, etc. Non-metals like nitrogen, the element which is well known for its abundance in the atmospheric air, is the most important nutrient for plants. Sulfur and phosphorus also form a part of the fertilizer industry. In addition to this common use, certain compounds are useful for specific purposes, such as phosphorus in the match industry. Similarly, common salt, a compound of chlorine, forms an important part of our diet. Metals in nature generally exist in the form of their compounds. The extraction of metals from their respective compounds involves various processes from simple mechanical crushing or grinding to complicated chemical reactions under specific conditions for a better yield. These processes are carried out in well-designed furnaces. Finally, these metals are purified to different extents based on their end use. All these processes come under the purview of metallurgy. The metals gain significance only due to their large number, but also due to their widespread use in various fields of the industry. And the role of non-metals is not insignificant in day-to-day life. The importance of oxygen and carbon in the biosphere is incredible. Apart from this, some non-metals in the form of their compounds occupy the most pivotal position in the industrial sector, and they are rightly called industrial chemicals. The elements are classified into metals, non-metals and semi-metals on the basis of their chemical properties. The metals appear at left hand side and middle part of the periodic table, and the non-metals appear at the right hand side of the periodic table. There are only 19 metals. Out of these, 7 are solid, 11 are gases and only 1 is liquid, that is bromine, at room temperature. Non-metals exist as solid, liquid or gas. They exhibit a wide range of physical properties in comparison to metals. At present, we have 92 metals in the periodic table. So, this is our periodic table. So, let us find out what are the characteristics of elements on the basis of which they are classified as metals. So next we will discuss properties of metals. The first property is physical state. Metals are solid at room temperature except mercury, which is liquid. Hardness. Metals are generally hard except the alkali metals such as sodium, potassium, etc., which are soft and can be easily cut with a knife. The hardness varies from metal to metal. The next property is tensile strength. Metals possesses high tensile strength. They can resist stretching without breaking. The next property is density. Metals generally possesses high densities except the alkali metals which have low density. The high density of metals is due to the presence of close packed structures in which strong attractive forces exist between the atoms of metals. Due to high densities, most metals are heavy. The densest metal is osmium and lightest metal is lithium. The next property is metallic luster. All metals in their pure state have a luster called metallic luster. All metals except copper and gold have a shining silvery white appearance. Metals have a large number of mobile electrons on their surface. These electrons absorb all the colors of white light which fall on them and go to higher energy state. They almost instantaneously come back to the lower energy state and emit all the absorbed radiations. Thus, the light reflected from the surface of metal is white, and as a result, metals appear lustrous. Most metals are lustrous in finely ground powder form, while in other form they appear grey or black. Metals appear lustrous when they are freshly cut and become dull on exposure to air. This is due to the formation of a thin layer of oxide, sulfide or carbonate on metal surface. When dull surface is rubbed with a sandpaper, the shining metallic luster reappears. Now, the next important property is malleability and ductility. Metals are malleable and ductile. Malleability is a property by which metals can be beaten into thin sheets with a hammer without breaking, and ductility is the property by which metals can be drawn into thin wires. The bonds holding the metal atoms are not rigid, unlike in electron pair bonds, and the metal atoms can easily be moved from one lattice side to another by application of force. These properties are attributed to the presence of strong attractive forces which hold the metal atoms of the sheet or wire together without breaking the metallic structure. Gold is the most malleable metal and silver is the most ductile metal. Gold can be hammered into foil much thinner than the thinnest paper. And about 2 km length of wire can be drawn from 1 gram of silver. Due to the properties of malleability and ductility, metals can be given different shape to make various articles. Now the next property is melting point and boiling point. Metals have high melting and boiling points except mercury and alkali metals which have comparatively lower melting and boiling points. The high melting and boiling points are due to the presence of closed packed structures, strong attractive forces which is called cohesive forces between the metal atoms, and strong metallic bonds arising out of metal-metal interaction. In a solid metal, the metal atoms are continuously vibrating in their crystal lattice positions. On application of heat to a metal, the amplitude of vibration of metal atom increases. If sufficient heat energy is supplied to the amplitude of vibration becomes so large that the attractive forces which hold the metal atoms together break. As a result, the metal atoms fall apart and move freely in the liquid state. If still more heat energy is supplied, the attractive forces between the metal atoms become still weaker and the metal boils when the vapor pressure of metals becomes equal to the atmospheric pressure. The metal having highest melting point. The highest melting point is of tungsten. Highest melting point. Tungsten, and the melting point temperature is 3643 Kelvin. The lowest melting point is of mercury, and it is around 234 Kelvin. And the metal having highest boiling point. Highest boiling point is of tungsten, obviously, and the temperature is 5773 Kelvin. Lowest boiling point is of mercury, it is 630 Kelvin. The metals having high densities usually exhibit high melting and boiling points. The metals with low densities usually exhibit low melting and boiling points. So the metals having high densities possesses close packed structures and strong attractive forces between the metal atoms. These are the properties of metals having high densities. Now coming to the next property, thermal and electrical conductivity. Metals are good conductors of heat and electricity. Silver is the best conductor of heat and electricity. Mercury and lead are comparatively poor conductors of heat. The electrical conductivity The electrical wires we use are coated with polyvinyl chloride, that is PVC, or polypropylene, which acts as insulator having very low conductivities so that the user does not get a shock on touching the insulated wire, and positive and negative terminals do not come in contact with each other. When a metal is heated, the heat energy increases the amplitude of vibration of metal atom. The heat energy is transferred to the electrons present in metal atoms, and the electrons acquire a large number of kinetic energy. As the electrons acquire a large amount of kinetic energy, the energetic electrons move through the metal and their energy is transferred to other electrons and the other metals situated at a distance away from the part being heated. Heat gets conducted from one part of the metal to the other parts of the metal. And due to the low ionization of energy of metals, the metal atoms in a metal lattice exist as cations by losing their valence electrons. A metal atom behaves as if it is an assembly of positive ions called kernels immersed in a sea of mobile electrons. We can see the structure of a metallic lattice. Structure of metallic lattice. These are the free electrons. This is metallic kernel, and these are the delocalized electrons. There is a complete freedom of movement of valence electrons from one metal atom to the other, and the valence electrons are not localized. The delocalized electrons no longer belong to one metal atom in particular, but rather to the metallic crystal as a whole. Each electrons belong to a number of positive ions, and each positive ions belong to a number of electrons. And this is called electron C model of metal or electron gas model of metals. How heat is conducted in a metallic lattice. We can see that this is the metallic kernel and these are the free electrons. This is heat energy. So electrons are free. They are in position to move in an electric field. The free mobile electrons account for higher electrical conductivity of metals. The next property is elasticity. Elasticity is the property by virtue of which a substance can recover its original form soon after the removal of the deforming force. This property is also due to the ease with which the metallic kernels can move from one lattice side to another. You might have observed that a small force is needed to bend a straight copper wire. The formation of sharp bend leads to the separation of some metal ions far from its nearest neighbors. So the previous pattern of atoms and electrons is broken and a new pattern is formed. And it's not easy to restore the previous pattern since a new pattern formed during bending does not usually fit together to generate the previous pattern, and the original pattern cannot be restored. So a small king always remains. The next property is electron emission. When a beam of light of suitable wavelength falls on a clean metal plate, electrons are emitted from the surface of metal. This occurs when the energy of the light that strikes a metal is great enough to overcome the attractive force between the positive metallic kernels and the electrons. The phenomenon of emission of electrons from the surface of a metal by the action of light is called photoelectric effect. Similarly, when heat energy is supplied to a metal, and if the heat energy is greater than the force of attraction between the positive metallic kernels and electrons, the electrons are emitted from the metal atom. The next property is sonority. Metals are sonorous. They produce sharp ringing sound when hit by an object. The next important property is formation of alloys. One of the most important property of metals is their ability to form alloys. What is an alloy? An alloy is a homogeneous mixture of a metal with other metals or with a metal and a non-metal. Alloys are also called solid solutions. The formation of alloy by metals is a physical property and it's not a chemical property. Iron is one of the most extensively used metal in the households and industries. It is never used in the pure state. Since pure iron is very soft, it possesses less mechanical strength and is elastic when hot. But when pure iron is mixed with a small amount of carbon, it becomes hard and strong. And when iron is alloyed with metals such as chromium and nickel, the resulting alloy is stainless steel. In contrast to pure iron, which is very soft and rusts, stainless steel is very hard and does not rust. Stainless steel is used in cutlery, utensils, machinery, and ornamental pieces. Thus, alloying a metal with another metal always leads to a change in properties as compared to the constituents. Alloys are engineering materials and are most extensively used in industries because most alloys have high melting and boiling points. They are resistant to corrosion and possesses high mechanical strength. Due to their high melting and boiling points and stability towards oxidations, alloys are preferentially used in electrical heating devices instead of pure metals. Alloys are made by first melting the major constituent at high temperature and then dissolving in it the minor constituents in a predetermined proportion. The alloy so formed is then cooled at room temperature. Alloys exhibit electrical conductivity which are less than that of the constituent metals. The common alloys and their constituent with their properties and uses are brass, constituents are copper and zinc. Its properties are it can be easily cut, strong, it is malleable and corrosion resistant. And the uses are in making castings, sheets, tubes, valves, screws, nuts, bolts, utensils, school bell, scientific instruments, telescope, microscope, barometers, and in decoration items. The another alloy is bronze, and its constituents are copper, tin, and zinc. Its properties are it is very strong, highly corrosion resistant. It is highly corrosion resistant. And the important uses are in making coins, metals, statues, machineries, and ships' propellers. The another alloy is steel. Its constituents are iron and carbon. And its properties, it is very strong, hard, and tough. It is very hard and tough. Its uses are in construction of bridges vehicles, ships, and as a building material. The next alloy is stainless steel, which is very much in use. Stainless steel. Its constituents are iron, chromium, and nickel. And its properties are: it is strong, hard, resistant to corrosion, and it is acid proof. And the uses of stainless steel are in making cutlery, utensils, ornamental pieces, and surgical instruments. So these are some common alloys, their constituents, properties, and uses. Thanks for watching Edupedia World Videos.